Hello, my name is Mandy Rosengren. I'm a Senior Solution Engineer here at NTOP, and today I will go through how we can generate dental splints and surgical stents within NTOP. So the first thing that we will do is go from scratch in an NTOP file and use our teeth scan to create our dental splints. And then we will take that file and adjust it so that it can be used as a custom block and can be a repeatable workflow for a collection of different scan data. So if you have not already explored our Intro to Automation course, I recommend doing that before going on to this one, as we will be creating custom blocks and discussing some of the similar topics for that. And then once we have that custom block, we'll test that out on a workflow, and then we will move on to generating our surgical stents, which will also have that foundation of that custom block for the dental splint that we created to use for our surgical stents. And we will go through a workflow for that to develop a surgical guide for a jaw that is missing teeth and see how this can be applied in different locations, and with different examples. We'll also go through how to label a part as well, as you can see here. And with that, let's get started in the software. Let's first open up a new instance of NTOP. So we're going to start completely from scratch for creating this initial dental splint workflow. And if you haven't already, download the mesh files, the lower jaw mesh and the upper jaw mesh, as we will take that, and I'm just going to drag that out of the file and into NTOP, and we'll be using these for generating our geometry. And now you can see this is not, our rough scan data. I've done some work in a separate NTOP file, kind of cleaning up this geometry so that we have a nice thing to work with for generating our dental splints. And we have our lower jaw and we have our upper jaw. And I'm going to convert these into implicit geometry. I will click on that and add our implicit body from mesh. And I will make these a variable as we will use them in generating our dental splint. So I'll right click, make this a variable, and label this our lower jaw. And same thing for our upper jaw. And I'll just relabel this our geometry section, or just geometry. I'll also save this file, so we can do File, Save, and I'm going to label it Dental Splint Workflow. Save that in my file location, and we can see it's also renamed our notebook. So we're going to use this as our base for generating our dental splint. So next step, I'll add another section, label this dental splint. And what I want to do is offset and smoothen this geometry to then get the desired dental splint that I want. I also have to consider if I want any gap between the dental splint and our actual teeth. So we want to apply that as well. So the key block that we will be using is the offset. Also, before I can input either the lower or the upper jaw, I'm actually going to right click and make this one a variable and just label this jaw, because we are going to want to switch out the lower and upper jaw, see how this workflow goes, and also we're going to be creating a custom block. So having that ability to easily kind of switch out the upper jaw, and we can X that out, versus the lower jaw, instead of just having to kind of rearrange all of our workflow for just the lower jaw or the upper jaw. So I'm going to put that also in my geometry section, and we'll start by just focusing on that lower jaw, but as I said, we can easily kind of switch out one versus the other. And I'll just, in the display, under color, I'm just changing this to slightly different colors, so as we're going through, we can compare and see how that differs with our geometry. Now, with our offset body, I'll just put in a number here. Let's put splint thickness is 0.4 millimeters, for instance. And what we can see if we do a section cut, so I'm going to type X, is that it's just offset our entire geometry, like so. And there's a couple things that we want to do. So one, we want to have some type of potential gap that the user can input. I also, as you can see, this is, fully covering our geometry. So right now we wouldn't be able to take this on or off. It's just completely encasing it. And there's also, as opposed to a shell, which is another method that I could have used as well, there's no opening in here as well too. It's a solid, so it's just an offset. So we have to do a couple more things than just that. Instead of offsetting by what the splint thickness is, I'm actually first going to offset by what my splint teeth gap will be. So I'll make this 0.2 millimeters, and let's right click and make this a variable, which I will label splint teeth gap. So now I have this. And then I will want to offset that even more so that I have my kind of solid geometry. So let's do another offset body, but we will be kind of adjusting this a little bit to have more options available. And then let's make this distance now that 0.4. So really the final edge of this is going to be then 0.6 away from the initial piece, but this is going to be our splint thickness. And just for syntax and kind of keeping things in the way that we showcase them in custom blocks later, I'm just making that splint uppercase. So now we have two offset bodies that we've used. And if we're doing kind of the simplest thing, first we would just do as a Boolean subtract. So because I'm going to be using this block multiple times, I'm going to make this a variable. So I'll make this a variable, and I'll just label this our cutting body offset, because we're going to kind of remove this inner offset body so that we have that gap between the two. So we're going to do a Boolean subtract of this initial offset, and maybe I make this a variable and label this actually outer layer by the cutting body offset. So now if we do a section cut, we can see I actually have a gap in here as opposed to just that solid. It still has some additional things that we need to address, such as it is fully closed still, so we need to cut it in some way. We also, in the custom block that I'll show later, I also want to have some ability to potentially smoothen it. So maybe I'm making a mouth guard that I want it to be a bit smoother. I don't want it to have all of these types of varieties that we're working with. Depending on what your application will be, you maybe want to have other options for that smoothing. So I want to have the ability to choose to either smoothen it or not smoothen it. So we're going to apply a smoothen body, and we can smoothen this cutting body offset. Let's say by that smoothen size is, grid size is 1 millimeter. So I'll bring that at the top too. And as you can see, I'm kind of starting to generate what I will use as inputs in my custom block later. So you could also bring these right into our input section if you're already thinking ahead of our custom blocks. But with the smoothen body, now we can see I have that interpolation type as linear. I'll change that to cubic so we don't have those kind of boxy shapes. And now we get something that's a bit smoother, but it is important to consider our initial geometry, because by smoothing this by that 1 millimeter, I am going to be getting something that is going into that geometry. So, for instance, I might want to increase that splint teeth gap if I am going with the smoothen body method. Or maybe I want to do a combination of decreasing that smoothing grid size, so it'll take a little longer to run, and increasing that. And so we get something that's, not necessarily as smooth, but if we look at this, we can see that I don't have that jaw going into it at all. But let's say I want to have this option, right, to choose to either have it smoothened in some way or not have it smoothened. So what I might want to do is add an if-else block. So with this if-else block, we can have a certain condition. I can say smoothen, for instance, so I'll right-click, make that a variable, and label it smoothen. So if I have this checked, then I do want my geometry to be, my final result to be that smoothen geometry as opposed to that kind of exact offset of our initial jaw. And if I don't have this checked, then it will not be smoothened. So if checked, then I want to use my smoothen body. And then if not checked, I will just choose to use our cutting body offset. And I'll just rename this smoothen cutting body. So now, instead of just using the cutting body offset for our outer layer, I'm going to use this if-else. So as we can see, I have that smoothened versus not smoothened. And let me increase this grid size a bit just so that we can have a better visual of that change. The other nice thing with the if-else is that the smoothen body can take a little while to run. But if I don't have this checked, for instance, and I adjust this grid size, we can see that this is an incomplete or an unbuilt block. So it won't take that time. If we did have a really small grid size, we wanted to quickly iterate over something, we didn't want to smoothen it at the end, maybe we wanted to attempt to smoothen it, we wouldn't have to wait for the smoothen body block to run unless we had this checked. But so then that would be kind of our outer layer. I also have to adjust my Boolean subtract because as we can see, this is using our cutting body offset as opposed to our final cutting body offset that may be a smoothened body, so it'll be a different result. So actually let me make this a variable, or if else, and label this final cutting body. So if we compare these two, we have that sharp and then we have that smoothen, which is why I saw those kind of gaps in our outer layer. And then now for my Boolean subtract, instead of using that initial offset that doesn't include that smoothen body, I'm going to use my final cutting body. So now what we'll see is something like this, where I have that opening inside, and it can either be smoothened or not. Now, I also want to, even though this does have that gap in there, I still couldn't put this into my actual teeth. So what I'm going to do is instead also include a plane in our Boolean subtract so that we can have that opening to take this off of the teeth. So I will add a plane from normal, and we can just drag that in there, and what we can see, if we look at our jaw, I can take my origin and just see how far we want that down. You can see that it's automatically adjusting. So let's say that's what I want for my dental splint, and I can make this a variable and label this cutoff region. And this allows me to only use a plane to cut this off, but maybe if I want to use a Boolean union of multiple planes, or I have some other type of geometry that I want to use to remove some of this, I might want to make this not just a plane, but an implicit body. Now, as you can see, I no longer visualize that plane because I'm having that as an implicit body geometry, but that'll just give us more abilities to trim. So that really gives us our dental splint that we've created. So I'm going to move this to our input section. I also, maybe I'll want to adjust this blend radius where I'm doing that Boolean subtract if I want to have not a sharp change. So we could make this a blend radius as well too. as a variable in our inputs. If we are thinking about then, creating a custom block for this. So we have most of our kind of key inputs that we want to see. I'll right click and make this final block just dental splint. And we can see that this will, if we wanted to switch out the lower jaw with the upper jaw, this will automatically generate. However, we do have that plane below this upper jaw, so that's why we're seeing something that's fully encompassing our teeth. So again, we'll want to move that, and we can see it's only trimming anything below the plane, so I'll want to change the normal to be -1 so that we get something like this. So we're pretty much done with our dental splint workflow. The last thing I want to do is create a fully custom block for this that I can apply to multiple teeth, for instance, or multiple scans that I have. So with our inputs, I have some of my inputs defined. I want to have my dental splint be the output, so I'll define that there. And then the other last key input that I might want to have is this jaw. And just looking also, if I open up these blocks again, if you want to adjust your smoothing iterations, we might want to put that also. If you wanted to change your interpolation type, you could also do that. So definitely look through and see if there's any of these variables that you might want to change. But that pretty much covers most of them, except for this jaw. So usually my last step is taking whatever implicit body I want in my kind of workflow. I will remove our lower and upper jaw and create that input at the top. So now I'm not using the lower upper jaw at all in this workflow. Once I have this custom block and I import it into another notebook, I will apply those lower and upper jaw there. So I can delete this entire geometry section. I'm not using it, and it just adds more file to the file size, for instance. And the other key things that I would say is write your description anytime you're writing a custom block. Also add inputs so that everyone knows what those values mean, if you have any specific notes for them. And to save on time, I already have my custom block created for this dental splint that has all the detailed descriptions. So I won't go through this now, but definitely if you are making your own custom block, I recommend doing that. And then the last thing you would do is file, save as dental splint. And I would just remove that workflow so that it's the same name as our file. And then we could go and open this up. So I'll save that. I could do File, New. And in our left side panel, we can import that dental splint that we have here with all of the inputs that we want. Now, since we just went through that dental splint workflow, I'm just going to go through, not from scratch, just with the completed file for the dental splint workflow that shows the custom blocks. So again, we have that lower and upper jaw, and they're just as mesh. And I have some of the inputs that we can change and adjust. And we can see this is my, if I go into my right-hand panel, and in the information, we can see that I have all the descriptions that are in the dental splint custom block that I created earlier. So we have all of those descriptions of what is happening with each section and what they do, and the description of the block. What we can see here is I have my upper jaw in here, my splint thickness, the teeth gap, an example cutoff region that I just have for this. If you're looking at the upper jaw, I have it at a bit of an angle. So it'll be kind of cutting down like so. Slight blend radius. I'm not smoothing it in this example, so I don't really have to look at those other two options. And what I can see as I get something like so. And I also have another cutoff region that we can see as an implicit, that is this cutoff lower jaw. And what we can see, I have it in the advanced. I won't go into too much detail. I have this for both the upper and the lower.
But if we want to compare what this looks like, so this is for my lower splint. Actually, let's compare the upper. So I'll go into my cut off upper jaw, and I will take this final one and use that instead for my cut off region. And so what you can see is that, let me copy and paste the differences between these two so we can really visualize it. Is that with my initial one, with just the example teeth, we're just using a plane. So you can see I have that excess geometry we probably don't want there. That would be kind of hitting into the gum. Some of these regions we maybe don't want to have included. So with the cutoff region that I'm using a field for, I am able to have something that is lower inside and then larger outside. So it's a bit better at kind of following the geometry that I want. And this one is a little bit more advanced, so I won't go, that's why I have it in that separate section. It uses our ramp block to basically ramp from the one type of kind of shape and structure that we're wanting to go to from the other. But if we look at that, so I have my upper jaw that we have here, upper plane, upper jaw. So those are the two kind of regions of cut planes that I want to do. And I basically mix between them. So if you want to learn more about kind of this topic, if you go inside this and you want to kind of create something similar, I recommend first going into our fields course in our NTOP Learn. But that's kind of the key thing, is that we're going from one plane to the next plane. So that's why we're seeing a kind of ramp between the two. And then we also have one additional ramp, which is just a reference field that we're using to then, as you can see, it's kind of adjusting it in the edges here as well too. So like I said, I won't go into too much detail, but it just shows a way that instead of just using a plane, you could use another solid, you could use a combination of different fields. That's why we wanted to keep that as an implicit body as opposed to just one plane. So again, the differences between those two. And then we can also view our lower splint and look at this with our lower jaw. And this one, again, we're seeing some of the cut off lower jaw region. That's again going to be a ramp. And just like I said before, we have our lower plane, lower value, and our upper plane, lower jaw. So we can see it's a little bit different. For these, they're not that as extreme as previous. But you can see that it is a little bit lower here at the top, higher at the other side. And then you can also see that this is also going and getting higher up, shorter distance for our geometry as we go farther back the end of the teeth. So that's another thing that this is going through and doing as well. So a lot of steps that are going within this that I won't go into detail today, but again, another example of how we can have that. And then also this is, again, not smoothened, so it's pretty quick to generate if I wanted to adjust, for instance, the splint thickness. Let's make that now 0.75. And you can see that it's very quickly changing that. And then if we want to, we can also smoothen that as well. It'll be a little bit of a slower process just because we're just going through that smoothing step, and that will take a little bit longer, but we get that same kind of result. But that's how we get something like our upper jaw and our dental splint. And this, so all of that work that we had done previously for creating this are now just within that custom block. And next, we will use this dental splint as well as some other key blocks in NTOP to generate our surgical stents.
Now that we've created our dental splint, we can then move to our surgical stent workflow. And we'll be beginning with that starter file that you can download below this video. That's the starter surgical stent workflow. It already has some of the key inputs that we discussed when we were creating our dental splint, and it also has some additional sections that are filled in. So I'll talk briefly about those and we'll get started from scratch. First one is the appendix starting geometry. So just as before, we have our lower jaw and our upper jaw. Now, we also have this upper jaw with teeth removed. So just to showcase, how we would use this surgical stent, I needed to remove some teeth. So I created a custom block that just is teeth removed. So I have specific points that I roughly am going to be removing those from, and actually looking at the upper jaw, that makes more sense. I have those 3 points here, and it just goes and roughly removes those. So that's really just to showcase this, and we can play around with different teeth locations to see how it can automatically generate. And same thing with the lower teeth. So I have my regions that I wanted to remove teeth for that as an example, and it'll just remove those from my workflow. So now really what I will be using is either the lower jaw missing teeth or the upper jaw missing teeth, and we'll get started. Now, before we get started generating our surgical stent, I am going to talk about an important area when it comes to most of these workflows, which is part labelization. And so I actually have already that section model labeled. And if we look at the left panel, I have some custom blocks already imported within this notebook. So dental splint we'll be using later, text label on part we'll be using soon, and cylinder from centroid. So since I already have it imported, I can just search for it in my notebook, which is text label on part. But if you wanted to use this again, you would need to export it, and then you could import it again into your next notebook. So for the body, I'm going to use this one, which is labeled lower jaw. Then we can say it's missing teeth one. At the location, I can choose where this is. So right now, that's not really an ideal location for my label. It's not even close to my part. And it doesn't have to be perfectly on that face. This workflow will automatically do that for us, but just want to have it so that it's at least close to that location. The text that I'm going to do, I'm going to use a serial number as an example. And you can also use dashes, for instance. I have letter spacing, that seems good. The length and width a little bit large, so I'm going to do 5 millimeters and 2 millimeters for the width. I'm also going to rotate this 90 degrees, just knowing what will happen. And I want to have it scale the width, not the length. And I want to have this engraved. So if we also look, if you want to see a little bit more information on all of this, for instance, when we go to that scale, so that's determining whether I'm going to lock the ratio between the length and the width. So it'll only use the length or the width when defining the size if I am going to lock the ratio. If I'm not going to lock the ratio, it'll be exactly those values, so the 5 and 2. And then for the text region, I'm just going to use a cylinder from centroid, so that's that custom block that we saw. I'll be using it a couple times in this workflow. We can see it automatically generated, so actually if I want to, I can right-click, make this manual red mode so it doesn't automatically start before I'm ready. And the center point, I want it to be roughly at the same location that I had my initial point. I could make this location a variable and just place this as the same center point, so actually I think I'll do that. And drag that in here. For the vector, I'm going to make this 0, 1, 0. So that's around where it'll be. And height, I'm going to make this about 16 millimeters, and radius is about 6.5. So we can see I have a large part. And if you're wondering what this kind of text region is, I didn't have to use a cylinder. I could have used a sphere or something as well too. But really what it's just saying is that we're going to be confining our label within this region. So if I don't want it to appear on both sides, if I just want it on that one side, that's what it'll do. So I didn't have to use a cylinder. I could have used any implicit body that would work. And what we can see is I now have my engraving here. And, I could play around with my location, see if I want it to be a little bit more over there, for instance. But a great and easy way to automatically kind of apply that label onto your part and keep track. And I'll just right-click, make this a variable, and I can label this labeled model. Now let's begin to create our guides and events. So let's open up this next section. This is going to be adding space at the open hole. So we're going to use that cylinder from Centroid custom block, and we're going to place them where we have those gaps in the teeth. So for the center point, I have my gap locations already defined in my input. And let's also define our height as our fill height, so we're going to kind of fill in those regions, and our radius as well. So that kind of fills in where we have those gaps in our teeth for the most part. And I'll make this a variable and just label this fill in. And then I'm going to union these to each other and to our lower jaw that's missing the teeth. So I'm going to do a Boolean union. Now this is 3 cylinders, so in order to then union it later to others, I could either use a concatenate list, concatenate 2 lists, or I'm just going to remove this implicit body list and place in that input. So now they will all be defined as just that one unit. Then I'm going to a Boolean union of this to our labeled model, and I also am going to have a blend radius. So I have that defined here. That's between that filled in region and the original model. And we can see I have that bit of a blend. I could always adjust that blend radius and see how that looks in comparison. But that's pretty easy to adjust and change as I have it as one of my inputs. But you could play around with that. I will stick with 1 millimeter for now. And now we can just make this a variable, and I'll label this filled in gaps. So now we have something like this that has those teeth regions kind of filled in. And we can now use our dental splint workflow that we created and use this as our reference model. So I'll open up my next section. And since I already have my dental splint imported into my notebook, I can just look for it. Now I have some of these inputs already defined. So before I put in the jaw, I'll do that one last just so it doesn't automatically generate. I have my cutoff plane already defined here. This one's going to be more on that simple side as opposed to the dental splint workflow where I had that scalar field. I'm just going to use this plane for the example. I want my interpolation type to be cubic. I'll change the smooth in size to 0.5, and I already have my splint thickness defined. So I'll drag and move that there. And for my splint teeth gap, I don't have that defined at top, so I'll just put that in. I'm going to have it as 1 millimeter, and I can add that to my inputs. And now everything's ready. I can use my filled in gaps as my jaw. And let's make this transparent so we can see how it looks. And as we can see, I have a bit of space in this, so just to kind of show this example, I have this dental splint workflow that I'm going to use for our surgical stent. So I'm just going to rename this, make it a variable, and I'll label it casing, the casing over the teeth. And now I'm going to create our guide walls for our stent and add some holes to where we had those cylinders placed. So I'm going to use a regular cylinder. And the reason I'm not using our cylinder from center point, I could also use that one as well, but we're not going to be placing these immediately at those points. I'm going to show another way that we can kind of place those points using, and those cylinders using our orient object. So just another method that we could use as well. And for point 1, right now I don't have to really look at the geometry because I just want to create the guide wall dimensions and then the hole as well. So I'm going to actually copy and paste because I'm going to be using 2 cylinders. So the first one, this is going to be our guide wall. And the second one will just be the hole that we are creating. And for the guide wall, I'm going to, instead of just defining these points, I have that hole depth defined already up here. So I'm going to point block. And for the X and Y, I'll keep that as 0, 0, so it's straight. But then for the hole depth, I'm going to make that the input that we have at the top. And for the radius, I'm going to use some of our logic. I'm going to use the add block. And I want to add the whole radius by the thickness of the splint. So we get something like so. And for the hole, again, I'm going to add a point block for our second point and only focus on the Z. And to keep it kind of automated so I can adjust, I'm going to use our add block again. And I want this to go through our guide wall. Let me make the guide wall transparent as well, and maybe a different color. So I want to add the whole depth. And then I also want it to go through our shell. So I'm going to do multiply splint thickness by 2. And then for the radius, this is just going to be the whole radius. So with this one, you can see I have the whole radius added by the splint thickness, so that it's going to be the same thickness of our actual splint that we were creating before, or stent. And then for the hole, this is just the whole radius that we've defined. And we can see it is sticking out just in the top here. So when I eventually do a Boolean subtract, and I subtract this part out, we will have that hole that we're creating. But this is not located where we need it to be, where we have those gaps of the teeth. So next I'm going to use an orient object. I'm going to take my guide wall, and I have a source plane that we're going to reference to where we're going to place this as our destination plane. So I'm going to use a plane from normal. And we can see like so on the bottom of our cylinder, which is fine. And I'll use another plane from normal to define where we're going to place the cylinder. So if I just have one, I just get one cylinder out of here, but I wanted to have it at all of the gap locations. So for the origin, that's where we're going to be. And just to view that adjustment, we can see that it's placed in that same location on the plane at each of those gap locations now. If we look at this, I actually want to adjust this slightly. So I'm going to use our pull points to plane so that I'm going to slightly adjust where I have those gap locations. And I'm going to make this -1 so that we're going to flip the direction of this plane. So I'm going to take our gap locations and I'm going to place it on instead on a different plane. And the plane is going to be, if we look at our splint, I'm going to take the bounds and I'm going to place it on the top of that. So I'm going to take the casing bounding box max point. And that's where I'm going to be pulling our initial points just right up to that plane, like so. So now if I place them here, we can see I've flipped the direction of our cylinders, and they're coming down from that max point. And if we look at this in comparison to our, let's see, our casing, for instance, we can see it's cutting through that like so. And now for the hole, I'll do the exact same thing. So first I'll make this a variable and I'll label this guide walls plural since I have more of those. And I can copy and paste. So I'm just using hotkeys, but you could also right click and choose copy, for instance. And I'll relabel this holes plural and replace the guide walls with the holes. So now what we can see is I have my guide walls and I have my holes sticking out. So then I want to trim my guide walls so that they are not sticking out, for instance. So I'm going to do an offset body of our filled-in gaps because this one, we can't use this to trim since it's already hollow on the inside. And I will take those filled-in gaps and I will offset it by the splint thickness. And then we have it trimmed so we can see it's within our region. And then I can union this to our casing. So I'll do a Boolean union of our trimmed guide walls with the casing. And I will also add a blend radius that we have defined here as the fill blend radius. Now we get something like this. Looks pretty similar in the top, but then we also have these cylinders on the bottom. And I will make a variable from this set of blocks and label this guide wall on stent. And then the last step, we'll move on to our final section. And I'm going to do a Boolean subtract of our guide wall stent with our holes. So here we can see I can also turn on the transparency, change the color a little bit, and compare this with our modeled label. But we get something like so. And maybe I want to increase that hole depth actually, so let's see that at, say, 12 millimeters. And all of it will automatically run. And we get something like so. And with the transparency, it's great to see that, maybe this is cutting in a little bit too much, so I can also adjust that accordingly. I can maybe change the gap locations, so this is really kind of that starting line, but then you could bring in your model and then adjust it exactly for your application or that specific jaw scan. But you get something like so. And then I will make this variable and label this our final stent. But we also, let's say we didn't have this gap, we just had these two gaps, then maybe we don't want to print out this entire thing. So it might make sense also to use a plane to remove certain areas. So you could also do Boolean subtract either at the same location, or you might want to apply a blend radius where this is my final stent, but maybe I just want to use a plane from normal. Let's have this at 1.50. And let's move this right around here. You can see it's adjusting that model as I'm going through that. And I'll change the color so you can see. Where I have something more like this. And I could add a blend radius, for instance, with that 1 millimeter that I have in the inputs at the edge so it's a bit smoother. And I'll just label this our final section. So again, I can adjust and this automatically generates so I can see what that looks like as I'm going through. So maybe that's more like the shape that I want. But you can play around with this. You might have to adjust some things for the upper jaw, but same type of process.